In the solvent, you reflected shapes across lines. Notice that when you reflect a figure, the shapes have opposite orientations. Two figures have opposite orientations if the corresponding vertices of the pre-image and image read in opposite directions. For example, note triangle BUG on the left. The vertices of triangle BUG read clockwise. Its reflection across this vertical dashed line, we get its image in blue, and the vertices of triangle B', U', G' are read counterclockwise. Notice that triangle BUG and triangle B', U', G' have opposite orientations. Key concept: reflection across a line. A reflection across a line M, called the line of reflection, is a transformation with the following properties. If a point A is on line M, then the image of A is itself. That is to say, A' equals A. If a point B is not on line M, then M is the perpendicular bisector of the segment BB'. So note the diagram. The pre-image B and its image B' are equidistant from the line of reflection. You write the reflection across M that takes P to P' as R sub M of P equals P'. You can use the equation of a line of reflection in the function notation. For example, R sub y equals x describes the reflection across the line y equals x. Problem 1, reflecting a point across a line. And this one's multiple choice. Point P has coordinates 3, 4. What are the coordinates of R sub y equals 1 of P? Our choices: A, 3, negative 4, B, 0, 4, C, 3, negative 2, or D, negative 3, negative 2. So we'll graph point P and the line of reflection, that's y equals 1. P and its reflection image across the line must be equidistant from the line of reflection. Move along the line through P that is perpendicular to the line of reflection, and stop when the distances of P and P' to the line of reflection are the same. Often I relate this to like wet ink on a piece of paper. If P was a wet ink drop on this piece of paper and you folded the paper at the line of reflection, y equals 1, P', the image of P, is where that wet ink would make another mark on the page. P is 3 units above the line, y equals 1. So P' must be 3 units below the line, y equals 1. The line y equals 1 is the perpendicular bisector of segment P'. If P' is 3, negative 2, the correct answer is C. Your turn. Point P has coordinates 3, 4. R sub x equals 1 of P equals P'. What are the coordinates of P'?